and we created a table, students, and we were able to insert a number of records into the table. And today we would be going over a number of things. So first of all, we're going to look at how joins work. And then we're going to look at iterations in SQL. And then we're going to briefly look at views and then stored procedures. So it's quite a lot to cover and not too much time. So we would try to go through this systematically. Well, before we can join two tables, we have to essentially add another table. So we are in a kind of a student environment. We already have our students table. Can anyone suggest another table that we can create that would be a supplementary table? So in addition to students, what else would be a good table to create? What about courses, right? Students get enrolled in courses, and so we can have courses and or classes, if you will, and then we can have enrollment table that tells us who is in what. So let's do just that. So as a kind of refresher, I would create a new table, and the command for that is intuitive. In SQL, when you think about the problem and you type the query, they're very close. So if I want to create a new table, the command will be create table, right? We learned that the last time. Right? So create table, and we'll call it classes. And we're going to have a class ID. And this is going to be an integer. This will be the primary key of the table. And we want, it's going to be an integer, it's going to be the primary key. But we want to be able to, in some sense, enter this by ourselves, right? We don't want this to be created automatically because we want to be able to kind of create our own, enter our own class ID, right? So, and then there would be the class description, which tells us, or maybe class name, which tells us the kind of class this is, right? So this would be variable character. So alphanumeric, for example, we could have IST 2510, which incidentally is the name of this class. IST 2510 has alphabets, I, S, T, and numbers, 2510. So alphanumeric. So in that sense, variable character would be sufficient. And would insist that the class name must not be longer than 50 and that it doesn't support null. And then we can have description. And this would be an overview of what the class is about. And this also is varchar. And we insist that whatever you have to say about the class cannot be longer than 300 characters. But you can also decide not to say anything. So this actually allows null. Right, so we would create this. And if you refresh, right, as usual, this was created in a different database. So we need to specify what database we want. And BA64 is where we would like to create this table. So let's run that again. And now we can refresh this. And we have students and classes. So the next table we'd like to create is enrollment. Enrollment. As usual, we're going to have the enrollment ID. And we're going to have the student ID, which is the enrollment ID. In this case, we want it to be automatically generated. So this draws from the identity function, starts at 1, increments by 1. Life is easy. So we have the student ID. So the student ID is it's an int, and it's a foreign key. and it references students dot student ID. And then we have the class ID. And of course, at any point here, we can say this is not null. And class ID will be an int, not null. All right, let's try this and see if it works. The why doesn't recognize this. We have students and we have student ID as a primary key. And I think it does not like the way we're writing it. I think it wants us to probably do it this way. All right, so that was the problem. Okay, it doesn't want the fully qualified. It wants us to specify the table name and the ID. All right. So now we have our final table. And we have the students table, the enrollments table, the classes table. And if you look at the columns here, you would see that we have two key columns in the enrollments table, the student ID, and which is a foreign key, and the enrollment ID, which is a primary key for the table. And you see that there is, in some sense, kind of a distinction there. So why don't we do this? So first of all, we should probably have made this a foreign key as well. So let's go to the enrollment table, and we can edit this. Just to make it easier, we go to design, and we can get rid of this. We can also set it here, but it's better to learn the query. So we can now alter this table, which is really what I'm going for, right? We can alter this table, and we can add class ID. And now we can have the same thing that we did before, foreign key, and it references classes. I believe that's the name of the table, and class ID. Okay, so let's do that. And now let's refresh and look at the columns, and you would see that now we have the enrollment which ID, which is the primary key, the foreign key here, which is class ID and student ID. And if you look at the columns themselves, you see how it looks. All right, so we're moving forward. So why did I do this? Why did I insist on this foreign key? Well, if I didn't insist on the foreign key, then you could put something, you can put a record in the enrollment table that doesn't really reference an actual student. And just to make my point, I would create another table and drop it later on. All right, so enrollment 2, right? So I'm going to make enrollment ID, student ID, int, blah, blah, blah. So I wouldn't specify a foreign key reference in this table. I would just make enrollment ID, student ID, and class ID, right? So let's create this. Good. So now if you refresh the tables, you would see that I have this table enrollment 2. So now let's insert into this table. Let's insert into enrollment 2. We're gonna have values. So let's insert. So first of all, I want to remind you of the students that we have, right? So we have student ID from 2 to 9, and we don't have anything in enrollments, sorry, in classes, right? Because we haven't inserted anything there, right? So all right, so students and classes, nothing in classes, but we only have student ID 2 to 9. Now look at this query that I'm about to write. I'm going to insert student ID 11 and class ID 200. And then I'm going to execute this query. And then I would select from enrollment table so you can see it. Enrollment 2 rather. All right, you can see this, that this worked, right? I was able to insert a student that doesn't exist because in our student table, we don't have a student. We don't have a student with ID 11. We don't have a class with ID 200, but I just inserted it into the enrollment table. The question is, can I do this with the actual enrollment table? Well, I was able to do it in enrollment 2, rather. Can I do this with the enrollment table, the one that has the foreign key constraints? Will it let me do this? Well, let's see. Let's see if it does. So we execute this, and it doesn't allow me to do it. It says that there is a conflict on student ID, and so there is a foreign key constraint that is enforced. There is no student with ID 11, so you will not be able to insert this record. So let's put an ID here that we know exists. So let's go for student 4. Let's see if I will be able to insert student 4 and class 200. We know that class 200 doesn't exist, so let's try. And it doesn't allow me either. It says that there is a class, there is a conflict on the class ID, right? So you cannot insert an enrollment with a class that doesn't exist because I have insisted on that foreign key constraint. Whereas I created the same table, they have the same column. The only difference is that there is no foreign key relationships here. And without the foreign key relationship, I can insert any data I want. And the data doesn't have to be correct. So I can make mistakes if I want. But once I have the foreign key relationship, then the data must exist in the referenced table. If the data doesn't exist in the reference table, it wouldn't allow me to insert them in the enrollment table. So this gives us some kind of safety, right? This foreign key reference, we call it referential integrity, right? There is the notion, this is our theoretical slide. So there is something called referential integrity. So when you have foreign keys specified, bad data will probably violate referential integrity. That is, data that doesn't exist will violate referential integrity and will not be inserted into the tables. Right? So specifying foreign key enforces referential integrity. So the takeaway from that is specifying foreign keys during table creation enforces referential integrity and keeps the data good. All right, so now that we know why I insisted that student ID and class ID should have a reference to the original table, meaning that it would be a foreign key in the enrollment table because of this thing called the referential integrity, which keeps us safe, which keeps the data safe. Okay, good. Let's move on. So now it's time for us to kind of insert some data into our table. So to do this, I would like to I would like to show you a number of things. First of all, the first thing is how do you declare variables in SQL, right? The way you do that is you use the declare keyword, declare, and then there is the @ every variable name must be preceded with @. So @ counter as int. Now I have this counter I've declared it as an integer. I can now set this counter to a number. I can set @ counter equals 0, and then I can select the variable here, select @ counter. And what do you think would happen when I run this code? Well, it will essentially print 0, right? I'm selecting @ counter equals to 0, right? And now it tells you, change the label to counter. Right? So if this is 5, right? So now I'm jumping ahead in our schedule. I'm going first to iteration because I want to insert records with an iterator, and then we would go back to joins. So it's kind of a one step ahead. So now let's do something fun, right? So why don't we change the value of this counter, right, in a loop, right? So let's do just that. So I could say while @ counter, which your counter is not equal to 10, right? I want to essentially I want to select this counter, right? So I have to also make sure that I am updating this variable. Otherwise, this loop will never end. So how do we do that? We talked about this before, right? The equation that doesn't make any sense or that is not possible at counter equals to at counter plus 1, right? Mathematically, this makes no sense, but I'm simply incrementing a variable and then I would select this here and let's see how this behaves, right? So of course it keeps selecting it and until it gets to 10 and then it stops. So it happens so fast you don't see the intermediate steps. Okay, good. So but we know that we can do things in an iterator. That's the point of this. So the notion of this is iteration, right? So if you run it on your computer, you would also see that this goes fast. And if we really want to see what's going on, then we might, you can see that it's executing. For those of you, just look at the bottom of my screen, you can see that now it's executing and is rolling and rolling until it completes. But we don't want to wait for this, so I will stop it. So the point is to show you that it's not a gimmick, it's actually doing something, right? So how can we use this to quickly insert how can we use this to quickly insert records into our table? Well, the first, let's insert a class, right? And then this class would be a general education class that everybody has to take, and then we can create an enrollment record for everybody that we have in our students table, right? So for a class, all we have to specify into classes, we have to specify a class ID, class name. So this class ID would be, 2200, why not? And the class name would be ISD 5000, and description would be machine learning. Or we can call it general machine learning, and this class, everybody must take it. All right. So now we're going to now, with this iterator, we are going to insert an enrollment record for everyone in our students table. So we're going to insist that the counter starts from 2, and we will move this to the bottom of the page. And here, inside of this loop, we're going to insert into enrollments or enrollment. And our student ID is going to be counter, right? Because and our class ID is going to be let's see what's in there. 2200. Okay. All right. Oh, I'm sorry. I was missing values. Okay, now it kind of worked. So let's see if what happened. Let's see what happened by selecting from the table. So we can immediately see that there is a problem in our code, and the problem is such that it it doesn't do this until the last one, right? It kind of worked, but it didn't. We wanted to do it one at a time, right? So, and there is a way to fix that. And what to do is that we need to actually have a begin and an end. And I think that once we do that, it will allow us to be able to do this one at a time. So let's try to do this again. Yep. Sorry about that. There we go. Now you can see that it worked. It did for every step. So now we can select stuff from enrollment, and this should be fine. Okay, so we have a duplicate, so we can get rid of we can delete from enrollment where enrollment ID is equals to 3. And when we select star from enrollment again, we should be good. Right, so 2, 3, 4, 5, 6, 7, 8. And okay, good. So we have all the students enrolled in the classes. And we were able to do the insert not manually one by one, but in a loop. And if you don't wrap your statement, right, in a begin and end, it doesn't do it one by one. It waits till the end, kind of like what happened when I increased this count this to a long, and let's get rid of this. And so now if I select at counter, you would see that it's going to print out one by one, right? Instead of waiting to do it. But if I get rid of this begin and end, it's going to do the iteration, and on the last one, then it will do this, right? So it's because this statement is somewhat incomplete, right? So it does the while loop, and then it executes the statements after it. So it doesn't think of this as being inside of the loop itself. So in a way, it is kind of incorrect code, but it's very easy to write it without thinking that your code is wrong, right? Especially if you write a lot of Python, you just indent the statements and you forget to put the begin and end, and then you wonder why it's not doing what it should do. Well, in SQL, you must explicitly put the begin and end before you put the body of the loop. That's my point. So this is like your curly braces in C#, and this would be equivalent to your colon, right, in Python. In Python, you put the colon. In C#, you put the curly brackets, and in SQL, we put the beginning and end. And then it would do it one step at a time. So, and just again, to illustrate the point, you can see that it enters the body and returns every single time. So in fact, this way, you're always getting a result every time, and you don't have to wait for the entire thing to finish. So if I tried the big number that I tried before, you would find out that, in fact, this would return every single time. I mean, it's still executing, it's still rolling like it did before, but the only difference now is like I can see what is going on. I can see what's happening. Like I can I know that it's doing something. So we're not gonna wait, so we're gonna stop it as usual. So anyway, and it was able to do 438. So this is quite slow. Yeah. So this is how to do iteration in SQL. You can declare your variables and you use the while loop, just like in any programming language. And then instead of the colon or the curly braces, you use begin and end, and then you put your instructions in the middle, and life is easy. Okay, good. So now that we've kind of talked about iteration and we have some data in our tables, we should look at joins. What are joins? And then after we look at joins, then we can think about executing some of the group statements that we had before, but this time with join. Okay, good. So imagine that let's comment out this code. Imagine the goal is to print out a report, and the report is going to show the name of the student, right? So let's also delete or drop table enrollment 2, because we don't need that anymore. That was just to explain referential integrity. All right, that's done. And if we refresh our list of tables, it should be gone. Okay, excellent. So now we want to print a report. We want the name of the students, the first name, the last name, the major, and we want to also print out the classes that they are enrolled in, right? So this is what we want to do. So how do we do that? So first name, last name, major, department, and classes. All right, so we will select from, right, students. What are we going to select from students? Well, first name. Last name. Also, we want to select the student ID. And there is a reason for that. Major and discipline. And sorry, department. Right? So if we executed this code right away, we're gonna get this result. But this is not all that we want. We also want the class that they are enrolled in. So to do that, we have to join the enrollment table. So all of a sudden, so let's execute this. And now you see why I wanted to select the student ID as well. Now that I am joining the enrollment table, student ID is now ambiguous. What that means is that it's in two places. Where do you want me to get it from? It's in enrollment table and it's also in the students table. right? So you have a column or a data attribute that exists in two tables. So now you have to break the tie. And a really nice way of doing this is by aliasing your tables. Students S, enrollments E. So this would allow us to be able to refer to them in the shorthand on. So now I can easily here say S dot student ID. So now when I execute this query now, it would work because it knows that it's going to get student ID from the students table because this S is an alias, right? S is an alias for students table. And E is it's an alias for enrollment table. So many of you have an alias, right? You know, maybe some of your friends call you Mac or Tom or something, you know, some English name because it's easier to just say a name in English, right? So maybe someone calls me, you know, sometimes I want to buy coffee and I say my name is Frank. My name is not Frank, but I say Frank because, you know, it's just easier than telling them what my name is. So that's an alias. And this is exactly what we're doing here. We just provide an alias for the students, and it's easy to use one character because then we can break the tie. I'm talking about student ID here and enrollments ID. So but I don't have to use the full name. I can just refer to the alias. And when the when a data attribute is in two places, I can break the tie by qualifying it with the alias, right? So you break the tie, you break the ambiguity of the tie by qualifying the data attributes using the alias. Right, so now we've done that. Now you've seen join in action. So now I have been able to join the enrollment, but I have not really selected anything from the enrollment table. Well, because quite frankly, there is really nothing that I want from the enrollment table. I'm joining the enrollment table so that I can do what? Join the students table. So I can now join the classes table. Classes C on C dot class ID equal to E dot class ID. Right? So now that I have joined the class ID to the students table using the enrollment table, now the enrollment table can be thought of as a mapping table, right? So the enrollment table here, can be thought of as a mapping table, right? It maps students to classes. That's its function. It simply maps students to classes. It takes a student and assigns them to a class. And now I can come here and say, C dot class name. I think we have that attribute, right? Dot class name. And let's execute this query and let's see what happens. And now you can see that I can see that all of these guys are enrolled in IST 5000. And if I wanted to see the description as well, I would say C dot description. There is a typo in the description. I missed the S, so I'm sorry. And general machine learning. So you can kind of see how joins work, and now you can kind of have ideas on how to do this again. You can group, right? You can say, well, I want to group by I want to group by gender, but based on the class, right? How do we do that? Well, so we want to select s dot gender. We don't need s because gender is not a bit ambiguous. We want to count gender, right? Where class ID is equals to 2200. And correct, this should be this, right? Okay, so let's try this. Yep, we forgot student. Students S. Class ID is ambiguous. So we have to specify which one we're talking about. So and we can use where here and it will be should be fine. All right. That's okay, this is good. Now let's do that. And now we have a result. Okay, so this would be the group or the finding the distribution of the class over gender that we did before, but now we're kind of this is within a join and we could the benefit here is we are restricting our data by class ID, which is not in the students table, right? So the join allows us to have constraints that is in another table, right? So for instance, we can have, say we want gender, we want to also height. Let's do height as well. Right? In fact, let's get rid of gender. Let's do height. think that should be correct. Height in centimeters. And we can see the frequency in terms of the distribution of height in the class, right? In this class. So we have two people are 165 centimeters, two people are 170 centimeters, and one person is 173, one person is 185, and one person is 190. So this is a distribution of height. But there is another thing we can do. We can say having height in centimeters, we can have even more constraints greater than 167. And you can see that the cardinality of the groups have reduced, meaning that we have less groups. So the group of 165 centimeters, that category is gone. So now, because we have a constraint here, the point of this is to show you that you can specify constraints on a group as well. And you don't want anyone short because you are thinking about forming a basketball team and you want to see the distribution of your players over a height random variable. You want to see how well they distribute into the categories of height that you've identified. So you are in this sense, you're thinking of maybe 6 feet is a category, 6'1", 6'2", etc. So you have this kind of discrete height values which form categories, and you want to see just how many you have. But you don't want to consider anyone short. So you can do that by having this constraint in the group class, right? So you can say having height greater than this, and that drops every other group that doesn't match this constraint. But you can also see that we have our where clause, which is another constraint on the data over which the group is being created. So the precedence of operation is that this gets executed, right? I first of all enforce the where clause on the select, and I have a result set, which I now group, right? Which now distributes over my height in centimeters variable. And then I enforce these constraints that I have identified in my group instruction. All right, okay. Anyone has any questions on this so far? All right, remember there will be homework on this problem, so you should ask questions in class. This is where we will clarify everything that you don't understand. Okay, so the where constraint works in the way that we've explained in the past. It allows you to constrain your data, your select queries, and your groups can also be constrained with the having clause, right? Groups can be constrained, the select query itself can be constrained, and they can all be used together, as we've seen in this example. So this is a superset or an example that contains both pieces, right? Both the select and the where, and the select and the group, right? With the having clause as the constraint. All right, so we have done join, iteration. We're now going to move on to views. So a view is a database object that you create. And the idea of a view is it's a query that potentially you run all the time, right? And considering that you run it all the time, you would like to not write the query all the time. You just want to essentially open a view and it will execute the query for you. So the query becomes a view of your data that you can repetitively access, right? So the data changes and evolves over time by different insert, update, and delete operations, and the view, responds to that, right? Gives you the current state of affairs in your database. So how do we do that? Well, very simple. I will take this query, for instance, and I can create view. I would give my view a name. So I would say this is some student basketball qualification. And then there is this nuance that says that you have to use the as keyword, right? So create view, there is a name, and then there is an as keyword, and you know you can create this view and put it in the database. The same thing also goes for stored procedure. Is in stored procedures you can do the same thing. So this is convention, right? In stored procedure, you can specify parameters, but in the view, you only need to put a name, you put the ask keyword, and the query. So before we even do this, let's do something even completely rudimentary. So let's call this check all students, or view all students rather. And the point of this is to show you that any query can be put into a view. So this would just be select first name, last name from students. So very simple query, and we would execute this first. And if you go to views, there is a folder called views under the database. You open it, you would see that there is now a view called view all students. And if you right click and you execute this, you would see that it works just fine. So you can select first name, last name from the view, and it will be good, right? So, or simply put, you can just select star from dbo.view all students. As you can see that IntelliSense is already showing me that view. And if I execute this, it brings everything for me. And you can even drop the DBO and simply execute like this, and it will just work. So this is in my database, right? I don't have to write that query again. I can just select all from this view and it would work. All right, so now that you've seen this simple example, we should be able to do this for this query as well. And in fact, that's what we will do. And now when we refresh these views, you would see that we have student basketball qualification. And if I select, let's go up, select star from student basketball qualification, it should be able to show me the results. And you can see that I have the result without having to write my query. All right. So here is the complicated query for the distribution of height, right? The distribution of my students over the height variable, right? The distribution of the students over the height variable, and you can see the frequency of the students that fall in each height category. It's a complicated group by statement, and somebody has sent me this code from Sydney in Australia, and I don't understand it. So I put it in a view, and every time I need to solve this problem, I can essentially just select from my view, and it will give me my result. So imagine that you're working at a corporation and your boss wants you to give him a report of the distribution of students over height, or the height distribution, another way of saying it. You can simply execute this view every morning, or at 6 p.m. or at 5:30 using a trigger, and email it to your boss directly, right? And yeah, and your boss will think you're working so hard to create a report, but it's all automated, right? Both the you write your trigger, executes the view, and if you're very good with SQL programming, you can also use SMTP to send an email to your boss right there from a start procedure, and this would run at 5 p.m. every day. And even though you're on vacation in Aruba and you're drinking margaritas, your boss would think you're working, but you're not working. Your automation is working for you. So my point is, this could be very useful. All right, so we have now done join, iteration, views. The last set of things for us to cover is stored procedure. But before we do that, I would like to give you like some kind of 10-minute break. So get coffee, drink water, and when you come back at 8:23, we would start procedures. Does this make sense? Everybody agrees? If you want a 10-minute break, can you raise your hand so I know if you want it or not? All right, okay, 2 people want a break. Only 2 people? Okay, good. Let's take 10 minutes break and we'll come back and we'll start with stored procedures. stop procedure? Well, a stop procedure is a function just like you have in Python or in C#. So you also have it in SQL as well, and it operates on your database objects, your tables, right? So it's a function that is a transformation defined on database objects, and the point is it performs efficiently on the on database transformations, and there are certain transformations that is more efficient if you do it in the data space than if you were getting the data and do it in Python, for instance, right? So there are certain functions that would be better if they are in the data space or they live alongside your data. And those kind of transformations, we define them in stored procedures. But in a general sense, you could write any instruction for the machine to execute in the stored procedure as well. You could write a calculator, right, as a stored procedure if you wanted. So you can kind of think of stored procedures as a way of being able to express yourself or write instructions to the machine using SQL. So you have, of course, limitations as to what you could do based on, but I would say for most objectives, right? You would find that you'll be surprised that you could do it in SQL. There are certain things, of course, that might be hard to do in SQL. I mean, it would be tough to render an HTML page, for instance, using stored procedures. I mean, because it's just not a natural fit for that kind of task, right? Or, terminating TLS using stored procedures is also not natural, right? It's not a natural task for stored procedures. So my point is that there are certain things that just doesn't fit. But there are other things that might not be ideal, but you could still do with stored procedures. Anyway, to kind of get things going, why don't we begin by just showing what the structure of a stored procedure is, a function that you can write in SQL and store in the database, and then we would kind of start with simple examples and go to complicated ones. So what's the syntax? Well, as expected, to create a stored procedure, it's create procedure, right? So we know that in SQL, the command for the things we like to do are very close to how we think about it. So create view is create view, create stored procedure is create procedure. And we don't have to say stored procedure because they're going to be stored. There are procedures that are being stored. Procedure is another way to say something is a routine or a function, if you will, right? So, and they are stored under programmability and sorry, not service broker, programmability, and you see stored procedure. So every stored procedure you create naturally get stored in this folder under programmability stored procedures. So you give the procedure a name, and for us, our first example would be to add numbers together, two numbers together. So we had two numbers. One of the differences between stored procedures and views is that you can have variables, and we know that variables in SQL must begin with the @sign. So number one, and number one is an integer, so like so, and number two, which is also an integer. And we learned from when we're working on the views that, in these programming languages, for instance, in Python, when you have a function, right, you have a function def add two numbers. And then you have number one. Have number two. And returns an integer. And then you have this thing, colon, right? You have the colon, and then still in Python, you return number 1 plus number 2, right? So this is your Python code. But the point is, immediately you want to give me the body of the function, you give me the column, and you give me the body of the function. Similarly, you have the as, and then you give me the body of the function. All right, so we have the as, and we would, as usual, we'll begin and end. We learned this when we were doing the iterator, that the body, kind of is wrapped in this envelope. And here I would also return number 1 plus number 2. Right. So I will create this procedure, and you can see that it's been executed successfully. And when I refresh this, you can see that there is a procedure here called add two numbers together. And I can execute this start procedure because it's a function, and I can provide values there, 5 plus 6. And when I execute this, I expect it to give me 11. And you can see that, in fact, returns 11. All right. So the question is this the only way that I can write this? So I am going to alter this procedure. If you want to change the procedure, you just alter the procedure, right? You can see. So instead of returning 1 and 2, I am going to declare ret as int, right? And then I'm going to set ret equal so this allows me to essentially set a variable here, and then I can return that. Let's get rid of this. Let's see what's wrong. It doesn't like well, it doesn't work because I forgot the @ sign, right? So it's really weird when you don't have good debugging information. All right, so essentially I'm just rewriting the I'm rewriting the function again. Instead of just returning the addition, I am assigning it to a variable, and I'm declaring a variable inside. So, and don't be like me, don't forget the @. It's really easy to forget and not see it because it's everywhere. So if it's missing in one variable, you might not know that it's missing, especially if your eyesight is bad. Okay. And there's not great debugging information. It just underlines things and you're not sure what's going on. Anyway, so let's execute this and then we can go back and execute the stop procedure again. And yeah, things are good. It's the same thing. So is there another way for us to potentially be able to get the same result? Well, the answer is yes. So let's get rid of this assignment. Let's simply select this and let's see if we get the same result. Okay, we would go back and execute the stop procedure with the same values, 7 and 8, 15. So you see it, there's a difference when I select the result instead of returning it. So there is something that you need to kind of observe here, that even though I am not returning anything, there is still a return value, which is 0. And this is because traditionally in C programming language, you have a program, you have a class. I'm going to write this the class, you have a program, and you have curly brackets, and then this class has an entry point, and it's you have an access modifier, and then you have a public int main, and then there is a set of arguments that it accepts, like so, and you have a also more curly brackets, and you have return 0. Right? And in C++, you would break the line like this. Well, must be C++ since we have a class. So my point is, this is the entry point to the program in C++ and C#, right? And especially in C++ and previously in C, there is this notion of return 0. It doesn't really matter. I mean, you could return something else, but even when the program doesn't need to return, for example, imagine that this program simply prints something. So print F, hello world. And this is all that this program is doing. So I'm not really returning anything to the calling user, but I still return 0, right? So it's kind of like a default, right? So a lot of programs written in C, C++, you see that there is a default value that gets returned as a consequence, as a return 0, right? So in C# today, you don't need this. You can just return void and you can get rid of this and you don't have to return anything. But in the old C, a function must return a value, and if there is nothing to do, you simply return 0. So there is this kind of notion where a function is something that does something and returns a value, and as such, since this is the principal definition, you must return 0. So as a consequence, you see that, SQL Server as well, even when you don't return anything, there is a 0 return value, which is kind of the default that you get. And it's, I don't know, but it's convention. It kind of inherits from this idea of C, C++, and applications that are implemented in C, C++ tend to kind of have this default return value as well. So, but if you're modifying, if you're doing arithmetic operation, instead of selecting your result, you can return, right? You can return. But there is a benefit to this. For example, I can select number 1 plus number 2, and I can select something like this. So I can do something like this, and let's alter the procedure, and let's execute this stop procedure. Like so. So now we can have 78 plus 22 should be 100. And oh yeah, so it fails there. Let's do it this way, right? Because I don't want to combat it. I just want to make my point. All right. All right, so here we go. So my point is you could have something like this. I mean this is poor because it's two columns and I really wanted my answers. But the idea or what I'm trying to say is that you can do more with the select statement. You could select the name, for instance, maybe Jesus Nunes. And you can do this as name. And you can do this as election result. So the point is you have more freedom with the select statement, whereas with the return, it has to be an integer. So now if I execute this stop procedure again with the same number, you would see that it says that Jesus Nunes election result is 100. Now it looks better. So select is more flexible when you're returning your result from a stop procedure, whereas if it's numeric, you can simply use the return keyword and return a number, right? And it would work. Okay, so let's go back to our original statement and we can set and we can return. All right, so this is our implementation. Okay, so why don't we do something that actually operates on the data? Okay, so we would use BA64. That's our database. I'm gonna make sure we're in the correct database. And want to create a start procedure that allows us to find the student by student ID. Okay, procedure. Find student by ID, and this takes a parameter student ID as an integer. As then will begin and end, right? And what do? We would select star from student table where student ID equals to @student ID, which is the parameter that we're accepting. And this is our stop procedure. And so this procedure is more useful than adding two numbers together because this actually operates on the data. So let's refresh our list of stop procedures here. And if we try to execute this, now it says give me student ID. So if I give student ID 2, it goes and finds that record for me, right? And it's Philip Morris, who has a male name, but is actually female and was born in 77. So if I change the student ID to 3 and I execute, it finds Paul Sapp, things like that. All right, so this is all well and good, but can I find a student by, say, first name, right? So let's go do that. Let's create a procedure where you can find student by first name. Okay, and this would be, you know, avatar, say 200. So this would be first name. So the question is, how would you do this, right? Do you want an exact match, or you want something close to it? So we want something close to it. We don't want an exact match because then it's tough. So because we don't need an exact match, we would say like, right? And all that has to happen is that whatever you give me should be a part of the first name. So it must contain, the first name must contain whatever you type. So this is what I want, but this is not how I would eventually have it. So this is it. It could have anything before and it could have anything after. Just that the first name must contain whatever you type in, right? So if you're looking for Rebecca and you type Becca or Beck, you know, I would find Rebecca because Rebecca contains Beck. So you can, if I'm looking for um, um, phone and I type PHU, it's going to work. If you know something, you know, if you're looking for, say, Donald Trump and you type Don, it would also work, you know. So that's the point of this. So this is wildcard character to match anything before and wildcard character to match anything after. But this is still not how I'm going to do it. I would, because I'm using a parameter, I would say match anything before if it's possible and match anything after. And this just injects the whatever parameter that you set, puts it here. Okay, so now that we have this going, let's create this new procedure. We will refresh our list of procedures here, and here we go. Find student by first name, and we can execute this procedure. And we know that there is a pause somewhere. So instead of spelling the Paul correctly, we just put Pau. And you can see that it correctly found Paul, and we only put Pau, right? So we didn't put the whole thing, and it's working. And so turns out that this is interesting, but probably not great. So how could we make this better? So let's create another procedure where you can find by name. This time it could be any part of the name, either first or last name, just whatever you remember about the name. So let's have a decent way of doing this then. So this could be, it could be the first name that I remember, or it could be the last name. Or it could be the last name. So you're beginning to see the beauty of star procedure because it allows me to essentially create interesting functions that are very, very useful. So now I have this function where you can find them by name, and it doesn't really matter which one. First name, last name, just whatever you remember. And now I'm going to execute this. And I will refresh my list of procedures. And now I am going to execute this. And I'm just going to put SAP, just something, SA. And here we go. Now you can see that it found two students for me. There is SAP, because it matched on the last name, and there is Sarah, that also matches on the first name. So it doesn't really matter what you remember about the person, as long as you remember something about their name, you can find them in the list of students, right? So stop procedures are very useful, and it allows you to be able to kind of reuse your code and parameterize your queries. All right. Um, what is another kind of interesting thing that we can do in stop procedure? So we could also, you could you could, for example, write a stop procedure to calculate grade point average, right? But to do that, you would have to create a grades table, right? And you have to create a grades table, and the grades table will be associated with the enrollment, right? So, of course, part of your homework this week would be to create these tables and to insert enrollment records for the students. And I want you to use iterations and joins and everything we discussed to do that. And then, of course, you're going to now write a program to calculate GPA. So I'm not going to show you how to do that. But I will show you how to use, you know, functions inside of your code. All right. So, for instance, let's assume we want to find the average of the height in the students, right? How would we do that? Well, we would say average height in centimeters. All right. So find students find students mean height. So find the mean of height distribution. Right? So let's do that. Let's create a procedure. So we refresh our procedures and we can execute this. Oh, so we will alter this procedure right away because we don't need this parameter and we're kind of taking it. So yeah. Okay, good. So we can now execute this stop procedure. And you can see it doesn't take any parameter from us. We click OK, and it tells us the average height is 172, right? It's 172. So that's an example of how to use an aggregate function in your code. And another thing you could do is maybe count the total number of students, right? So this is a stop procedure that just tells us how many students we have. And when we do this, we want to count based on the student ID, right? We want to only count students that have student ID, which will be the same thing as count star because student ID is compulsory, it's generated automatically. But there is a difference between count star and counting the number of records in a table where a column has a value, which is what this is doing. It counts the number of records in the table where student ID column has a value. All right, so we're gonna total number of students. Right, we would do this, and we would refresh our list of stop procedures. And if you execute this, doesn't take any parameter as well, tells us we have 8 total students in the class. So again, you can kind of see how you can use these aggregate functions inside of your code, creating stop procedure. And also, it goes without saying that you can have things like creating groups as well in your stop procedure. So let's Let's copy the code from our view. Not this one, but that one. I simply want to copy this code. So I don't need this. And let's see if we can create find basketballers. Okay, we can also do the same thing. What we did in the view, we can do with stop procedures. We will call it find basketballers, and yeah, and we execute. And we refresh this and find basketballers, we would execute. So in this case, there really isn't any difference between the start procedure and the view. They would return the same thing. You can see it gives us a distribution of the students over the height variable, and we can see now just how the students distribute in the height categories. All right, so this is the main idea that I wanted to show you this week. And next week, sorry, of course, the assignment this week is going to be on writing a lot of programs in SQL. So there's going to be a lot of it, and you would have to kind of practice a lot. So that's the that's where we're going to stop today. Any questions? No questions. So this is very easy then. I expect everybody to do exceptionally well. So like I said before, make sure you start the homework on time, particularly this week. Anne, I think you have a question. Go on.
I don't think I have a question related to the lecture today, but
Uh-huh.
just want to notice you that we will have a public holiday starting from Friday to Wednesday. Yeah, next Tuesday, I think it's our Independence Day in Vietnam.
Okay.
So most of us will have a public holiday. So it would be great if you could help us like postpone the deadline for the homework a little bit, because we will be reuniting with our family in our home.
So tell me, when do you want the deadline to be?
It would be great if you could delay it until maybe Thursday.
Thursday. Okay, good. Thursday by midnight.
Yes, it would be
Okay,
great. Thank you.
all right. Okay, Thursday then by midnight. So in fact, why don't we make it Friday? So you don't have good amount
Oh,
of
that
time
would be
to.
amazing. Thank you.
Okay, we will do it on a Friday by midnight, so you have time to work the problems, right?
Yeah,
Okay.
thank you
So,
so
but
much.
what about our class on Wednesday? Are we still able to do that?
Our class will be on Thursday, so it
Oh
will
yeah,
be,
sorry.
yeah.
Forgive me. It's Wednesday for me, Thursday for you.
Oh, it's okay.
I
Thank you
forgot.
anyway.
Okay. All right. Thank you guys. And yeah, we'll see next week and I would postpone the deadline. Bye bye.